Hello friend, first of all I would like to express my warmest wishes for all of you on the beginning of new academic year. In this lab we will talk about the coordination chemistry, which is the part of inorganic chemistry deals with transition metal. Transition metal are located in the middle of the periodic table, sometimes called D block. Before we start talking about the coordination chemistry, we have to know what is salt, what we mean by the salt, and what is the type of salt, how many types of salt we have. Simple salt has prepared by combination of two different ion, one cation and one anion. Like this one, we have sodium, which is cation, and chlorine, which is anion, combined together to form NaCl salt. This one is simple salt. Why we call it simple salt? Simple salt completely dissociates into its ion when dissolved in water. For example, if we dissolve any one of these salts like NaCl or sodium chloride, potassium nitrate or copper sulfate in H2O, they dissolve completely to its simple ion. Like NaCl dissolved in water, the product is sodium plus and chlorine minus, simple ion. Simple salt gives simple ion when added to water. Therefore it's called simple, because when it dissociates give its simple form, simple ion. Double salt is compound prepared by combination of two different salt compound. Double salt completely dissociate into its ion in water. Double salt gives simple ion when added to water. For example, more salt. Like simple salt, the double salts completely dissociate to its simple ion. But the difference between double salt and simple salt prepared from two different ion. We have two different ion. We have simple ion combined together to form simple salt. But double salt prepared by combination of two different salt compound. Here the starting material is not simple ion, but the starting material is simple salt with another salt to form double salt. And like the simple salt, the double salt completely dissociate in water to its simple ion. And double salt gives simple ion when added to water. For example, more salt. The starting material, as we see here, iron sulfate plus ammonium sulfate. We have two different salts. Each one of this salt combined together to form more salt. After dissociation of this salt in water, it's, as we mentioned before, completely dissociate into its ion in water and give simple ion. For example, iron sulfate are dissociate to iron plus 2 plus sulfate. We have sulfate here and sulfate with ammonium sulfate. That means we have two sulfates and ammonium by 2, also 2 ammonium ion plus 6 H2O molecule. Complex salt. Our lab will focus on this type of salt, which we called complex salt or complex in general. Complex salt is a compound composed of central metal atom having coordination bond with ligand around it. Here we have an additional type of bond. In the simple and double salt, the type of bond between the ions is ionic bond. Here we have coordination bond between the ligand and central metal atom. Complex salt do not completely dissociate in water into its ion in water. Complex salt do not give simple ion. For example, when we dissolve potassium ferrocyanate and tetraamine copper sulfate, do not give simple ion like this example. We have tetraamine copper sulfate. During dissociation, after dissolving in water, the product is not simple ion like simple salt and double salt. Here we have simple ion, but here we have complex ion. It's not simple form of atoms. Or we have tetraamine copper plus 2 as a complex ion with sulfate ion. That means the complex do not dissociate completely. It's partially decomposed, partially dissolved, and the product is not simple ion. We have complex ion and counter ion. The difference between the covalent bond and ionic bond. Covalent bond involves sharing of electron. That means we have two atoms, each one share with one electron to form covalent bond. But ionic bond involves transferring of electron associated with each bonding atom. That means we have one atom lose electron and another atom accept electron. As a result, the ionic bond is formed.
Carbon atom holds 4 electrons in its outer shell, but it would be much more stable with 8. To gain the additional 4 electrons, carbon can share with other atoms, and thereby have a completed outer shell. If one carbon and 4 hydrogen atoms come together and share their electrons, carbon achieves an octet of electrons. Note that each hydrogen in this compound achieves 2 electrons in its outer shell. This is the stable configuration of the first electron share. Between sodium and chlorine atoms is an example of how an ionic bond is formed. Since sodium has only 1 electron in its third shell, it has a tendency to give up that electron. Once it does, the remaining outer shell contains 8 electrons. This loss of an electron gives sodium a slightly positive charge. Chlorine, on the other hand, tends to gain an electron, since its outer shell already has 7. When chlorine gains an electron, it becomes slightly negative. The charged sodium and chlorine atoms are called ions. Ions of opposite charge attract each other and form ionic bonds. In this case, the attraction of sodium and chlorine form a molecule called sodium chloride, or table.
As we note here, the atom carbon and hydrogen formed covalent bond. Each one shared 1 electron with another atom to form covalent bond. Carbon have 4 electrons in outer shell and hydrogen have 1 electron. 4 hydrogen with 1 carbon form CH4 with total number of electron 8 electron on carbon and 2 electron on the hydrogen. Here we have sharing electron, but in ionic bond sodium have only 1 electron and outer shell, therefore tend to lose it, while chlorine have 7 electron, tend to accept 1 electron to form ionic bond between the sodium and chlorine. Sodium carry positive charge because it lose 1 electron, and chlorine accept 1 electron. But in transition metal, the phenomena is completely different from the ionic bond and covalent bond. Transition metal do not normally bond in this fashion. They primarily form coordinate covalent bond, a form of Lewis acid-base interaction in which both of electrons in the bond are contributed by donor Lewis base to an acceptor Lewis acid. So here we have lone pair donor Lewis base and lone pair acceptor Lewis acid. This lab serves as interaction. This lab serves as introduction to area of synthetic chemistry, and more specifically to inorganic synthesis. You are going to make some new chemical bond as you synthesize the large molecule from smaller one. You will be synthesizing a coordination compound. The bonds in coordination compounds are 2 electron bonds, like covalent bonds. But the electron come from the ligand, Lewis base with unpaired electron. The difference between the covalent bond and the coordination or coordinate covalent bond, the both of
nitrogen has 5 valence
electron
electron. It
come
forms
from
3
the
covalent
same
bond to complete its octet.
atom. From
Hydrogen
the
has 1
Lewis
valence electron.
base,
It forms
which is
single covalent
donate
bond to complete its
unshared
duplet.
pair of electron to the Lewis
Nitrogen
acid,
shares
which
3
is
electrons with
electron
hydrogen
pair
atom, and the
acceptor.
non-bonded electron pair of
The
nitrogen
metal
is called
ions
lone
serve
pair.
as Lewis acid, an electron deficient species. Have empty
Boron
orbital,
has 3
which can
electrons
be
in its
used
valence
its
shell.
empty orbital
Boron
for the
shares its
bond.
3 electrons with fluorine, which has 7 valence shell electrons.
The
Even
picture
after this
below
sharing of electrons,
show
boron
the
has
ligand
deficit of 2
we
electrons
will
in its
be
outermost
using
shell.
and the presentation of the bonding in the coordination complex. As we see here, we have
BF3 approaches
nitrogen
to NH3 with a
atom.
lone pair
Nitrogen
of electrons. This
atom
lone pair of
have
nitrogen is
unshared
donated to
pair of
boron for
electron.
sharing and a dative
Also,
bond is
chlorine
formed.
atom have unshared pair of electron. Therefore, these two atoms have the ability to form coordination bond. This atom act as Lewis
Equivalent bond in which
base,
the shared pair of
have
electrons
the
is
ability
donated by
to
one
donate
atom and is
unshared
accepted by
pair of
other atom
electron
is
to
called
central
dative
metal
or
atom,
coordinate covalent
Lewis
bond.
acid.
Nitrogen has 5 valence electrons. It forms 3 covalent bonds to complete its octet. Hydrogen has 1 valence electron. It forms single covalent bond to complete its duplet. Nitrogen shares 3 electrons with hydrogen atom, and the non-bonded electron pair of nitrogen is called lone pair. Boron has 3 electrons in its valence shell. Boron shares its 3 electrons with fluorine, which has 7 valence shell electrons. Even after this sharing of electron, boron has deficit of 2 electrons in its outermost shell. BF3 approaches to NH3 with a lone pair of electrons. This lone pair of nitrogen is donated to boron for sharing and a dative bond is formed. A covalent bond in which the shared pair of electrons is donated by one atom and is accepted by other atom is called dative or coordinate covalent bond. Nitrogen has 5 valence electrons. It forms 3 covalent bonds to complete its octet. Hydrogen has 1 valence electron. It forms single covalent bond to complete its duplet.
The Lewis acid in coordination complex, often called central metal ion or atom, is often a transition metal or inner transition metal. Although main group element can also form coordination compounds. The Lewis base donor called ligand can be a wide variety of chemical atoms, molecules, or ions. The only requirement is that they have one or more electron pair. That means the criteria here is to have at least one unshared pair of electron. It must have lone pair of electron to act as Lewis base, as a ligand, which can be donated to central metal atom. Central metal atom must have deficient or vacant orbital. Most often this involves a donor atom with a lone pair of electrons that can form a coordinate bond to the metal. As we note here, we have scandium as central metal atom with 6 H2O molecule. H2O molecules have oxygen and shared pair of electron, act as a ligand, have the ability to donate this lone pair of electron to the scandium with empty orbital, with D empty orbital in D. In the first example, we have covalent bond because each atom shares with one electron from carbon with one from the hydrogen. The second example, ionic bond, because sodium loses one electron and chlorine accept one electron. As a result, the ionic bond form. In the covalent bond, coordinate covalent bond, the lone pair of electron, both of electron come from the same source, come from the oxygen with unshared pair of electron, and scandium have empty orbital, have the ability to accept unshared pair of electron. Therefore, H2O called ligand and scandium called central metal atom. Coordinate covalent bond involve electron from the Lewis base being donated to a metal center, as we said before. The lone pair from the 6 water molecule from the bond to the scandium ion form an octahedral complex. Here the geometry of this complex is octahedral because we have 6 water molecules, we have 6 ligands are attached to the central metal atom, to scandium, to acceptor The coordination sphere consists of the central metal ion or atom plus its attached ligand. Brackets in the formula enclose the coordination sphere. Spaces outside the brackets are not part of the coordination sphere. So inside the brackets we have coordination sphere, which consists inside the coordination this brackets we have central metal atoms and ligands. Any atom or ion outside of this bracket, it's not part of coordination sphere. It's not part of coordination sphere. The coordination number of the central metal ions or atom is the number of donor atom bound to it. Point of attachment between the central metal atom with ligand is called coordination number. As much as the attachment point or donor atom increase in the ligand, the coordination number also increase. The coordination number of the silver in the example number 1 is 2 because we have 2 ligand. Our ligand ammonia. Ammonia have nitrogen atom, only one donor atom, which is nitrogen. And we have 2 ammonia, that means the coordination number is 2. For copper ion, in tetrachlorocopper, we have 4 chlorine atom, that means the coordination number is 4 because only one donor atom, each ligand with one donor atom. The coordination number 4, whereas for the cobalt ion is coordination number 6. We have 6 water molecules, 6 aqua ligand. Each H2O molecule have only one donor atom, one oxygen, therefore its oxidation or coordination number equal to 6. The coordination number is 6. Each of this ligand is monodentate ligand. Ammonia, chlorine and water is considered as monodentate ligand because each one have only one donor atom, have one tooth, one point of attachment with ligand. From the Greek for one tooth, meaning that they connect with the central metal through only one atom. In this case, the number of the ligand and the coordination number are equal because only one donor. As shown here, silver attached with 2 nitrogen, coordination number is 2. Copper are contact with 4 chlorine and coordination number is 4. Cobalt are attached to 6 oxygen atom, 6 aqua ligand, therefore coordination number is equal 6. And the geometry of this complex linear, first one, and tetrahedral, second one, and octahedral, third one. But we have other type of ligand. Many other ligand coordinate to metal in more complex fashion. This one is called bidentate or polydentate ligand. Are this in which 2 atoms coordinate into the metal center. For example, ethylene diamine. Ethylene diamine, En, abstract as En, ethylene diamine. This is considered bidentate ligand. The coordination number for each one molecule equal 2 because we have 2 nitrogen here. We have 2 point of attachment. We have 2 donor atom in single ligand. Although we have only one ligand, but this ligand contains 2 donor atom. 2 points of attachment between the ligand and central metal atom. 2 nitrogen atoms, each of which has 1 lone pair and can serve as Lewis base. Both of atoms can coordinate to single metal center. In the complex tris ethylene diamine cobalt, there are 3 bidentate ligands, ethylene diamine, and the coordination number of cobalt is 6 because each one ethylene diamine is bidentate ligand, and we have 3 bidentate. 3 multiplied by 2 equals 6. Therefore, the total coordination number equal to 6. The most common coordination number are 2, 4, 6, but example of all coordination number from 1 to 50 are known. The ethylene diamine ligand contains 2 atoms with 1 pair that can coordinate to the metal center. The cobalt complex contains 3 of this ligand, each forming 2 bonds with cobalt ion. Any ligand that bonds to central metal ion by more than 1 donor atom is a polydentate ligand, money teeth, because it can bite into the metal center with more than 1 bond. The term chelate, pronounced as chelate, from the Greek for claw, is also used to describe this type of interaction. Many polydentate ligands are chelating ligands, and a complex consisting of 1 or more of this ligand and a central metal is chelate. The chelating ligand is also known as chelating agent. We call it chelate because we have more than 1 donor atom. Like following example, we have 4 nitrogen. The coordination number here of iron is 4 because we have only 1 ligand but with 4 donor atom. We have polydentate ligand. The coordination number of iron here is 4 because we have 4 nitrogen. Coordination chemistry is the branch of chemistry deals with coordination compound. As we mentioned before, coordination chemistry is branch of coordination compound. Coordination bond is the branch of chemical bond, another type of bond formed by denoting electron pair from the ligand Lewis base to central atom Lewis acid. Coordination compound is an organic compound consists of counter ion and complex ion, which consist of ligand Lewis base bind with central atom Lewis acid. By coordination bond, we have central metal atom Lewis acid bind with ligand Lewis base to form coordinate covalent bond. Coordination number of coordinate covalent bond to the central metal atom in the complex, or the number of closest contact to an atom in the crystalline form. Number of attachment point between the ligand and central metal atom, between the donor atom in the ligand and central metal atom is called coordination number. As much as we have more than 1 attachment point between the donor atom and the central metal atom, that means the coordination number increase depending on this attachment point. Coordination sphere: central metal atom or ion plus the attached ligand of the complex. Inside the coordination sphere we have two compounds. One of them is central metal atom, Lewis acid, with ligand, Lewis base. Central metal ion or atom which one or more ligand is attached through coordinate covalent bond. Counter ion is any ion which binds with complex ion by ionic bond to neutralize the charge of the complex ion like potassium, calcium, sodium. And counter ion is found out of coordination sphere. The rules of counter ion to neutralize the charge of central metal atom. Ligand, ion or neutral molecule attached to central ion in coordination compound. Ligand is Lewis base which attached to central metal atom by coordinate covalent bond. Donor atom, atom in the ligand. Inside the ligand we have many atoms, but the donor atom with lone pair of electrons that form coordinate bond to the central atom. Because inside the ligand we have more than one atom, but only atom with at least one lone pair of electrons act as Lewis base, have the ability to form coordinate covalent bond with central metal atom. Chelate, complex form polydentate ligand attached to central metal atom. The bidentate or more have the ability to form chelate ligand or chelate ligand with central metal atom because it have more than one donor atom. Chelating ligand, ligand that attach to central metal ion by bond from two or more than atoms. Only monodentate ligand cannot be considered as chelate ligand, but the bidentate or tridentate, tetradentate, and other type can be considered as chelating ligand. All polydentate ligand can be considered as chelating ligand. Example of monodentate ligand that attach to central metal atom through just one coordinate covalent bond. Monodentate ligand like aqua H2O molecule or amine NH3 or chlorine Cl-. Other example fluorine, chlorine, bromine, iodine, and aqua, amine, O2, CO, and CO2, and hydroxide group. Bidentate ligand, ligand that coordinate to one central metal through coordinate bond from the two different atoms. Bidentate ligand like oxalate and dimethyl glyoximate or carbonate ion. Here we have more than one donor atom. Polydentate ligand, ligand that attach to central metal ion by bonds from two or more donor atom. Multidentate ligand like ethylene diamine tetraacetic acid. Here we have 6 donor atom, 4 oxygen with 2 nitrogen. Coordination compound or complex. We have central metal atom, which is called Lewis acid, have the ability to accept lone pair of electron or acceptor. And also we have ligand, donor, Lewis base, have the ability to donate lone pair of electron. Also we have coordination sphere. Inside coordination sphere we have Lewis acid with Lewis base. We have central metal atom and ligand. Outside of coordination sphere we have counter ion used to neutralize the charge of central metal atom. As explained here, we have cobalt ion, central metal ion, Lewis acid, and we have 2 ligands, chlorine and ammonia. This is Lewis base. have a lone pair of electrons. Each of chlorine and a nitrogen in ammonia molecule have donor atom, have the ability to form coordinate covalent bond between the ligand and central metal atom. We have two ligand chlorine and 4 ammonium ligand. As a result, the total coordination number of central metal atom of cobalt equal to 6, because we have 4 ammonia and 2 chlorine. The total coordination number is 6. The bond between the cobalt and chlorine and ammonia is coordinate covalent bond between the central metal atom and ligand. The square bracket is called coordination sphere, which contain central metal atom and ligand. Out of coordination sphere, we have counter ion. Counter ion used to neutralize the charge of complex. The oxidation number of the complex is +1. Therefore, we need counter ion with -1 to obtain a neutralized or neutral complex. The total charge of complex is equal to 0. Here we have 2 chlorine, each chlorine with -1. That means cobalt must be +3. +3 -2 equal +1. +1 -1 equal 0. Total charge is 0. Thank you for listening.